Hello, welcome to today's class. In today's class, we will talk about Boolean algebra. But before we look at what Boolean algebra is, let me mention about two important events that happened in the field of digital circuits. And the first event is happened in 1854 when George Boole developed an algebraic system for the systematic treatment of logic. This algebraic system was called the Boolean algebra. Although introduced in 1854, this algebraic system did not find any practical applications until 1937 when Claude Shannon introduced a two-valued Boolean algebra called the switching algebra and demonstrated that switching circuits can be represented by this algebra. It was the application of Boolean algebra to the design of digital circuits that simplified the design process, and it was because of the introduction of these theories that in modern days we can have complex digital circuits which have like billions of switches in it. Next, we want to talk about Boolean algebra. So Boolean algebra is an algebraic structure defined on a set of elements B together with two binary operators plus and dot. So to have a Boolean algebra, first we need to have a set of elements B, and then we need two binary operators plus and dot. We can define these two operators in any way we want. However, they have to satisfy certain conditions. And the first condition that needs to be satisfied is that the set B has to be closed with respect to the operator plus, and the set B has to be closed with respect to the operator dot also. Now what we mean by closed, let us understand using this example. So let us consider the set of positive integers z plus. So z plus is the set of positive integers like 1, 2, 3, 4 and so on. Now if we take any two elements from this set and we add them, the sum will also belong to this set. For example, if the two elements that we take is 1 and 3 and add them, the sum will be 4, and 4 is a member of this set. So we can do this addition for any two numbers from this set, and you will find that the sum will always be a member of the set, and hence we can say that z plus is closed with respect to the addition operation. However, if we perform subtraction between any two elements, the difference may not always belong to z plus. An example of it is if we do 1 minus 3, the difference is minus 2, and minus 2 is not a member of z plus, because in z plus we only have positive integers. So here if we take any two elements from z plus and we perform the subtraction, the difference may not belong to the set, and hence we say that z plus is not closed with respect to the subtraction operation. Now for an algebraic system to be a Boolean algebra, we have to define the two operators plus and dot in such a way that B has to be closed with respect to plus and B has to be closed with respect to dot. So we cannot have arbitrary definition. We cannot have arbitrary definitions for plus and dot. The next condition is that there should be an identity element with respect to plus, which we can designate by the symbol 0, and if the element is an identity element, then x plus 0 should be equal to 0 plus x, which should be equal to x. So when we define the operator plus, it should result in an element from set B to become the identity element with respect to plus. And what is the meaning of the identity element with respect to plus? If we take any element x from the set B and then we do plus with the identity element, it should result in x itself. Similarly, we will need an identity element with respect to dot. And the symbol that we will use to represent an identity element with respect to dot is 1. So if an element is an identity element with respect to dot, it will satisfy the condition that x dot 1 will be equal to x. The third condition that needs to be satisfied is the commutative property. And what we mean by commutative is that if we take any two elements x and y from the set B, then x plus y should be equal to y plus x, and x dot y should be equal to y dot x. So so the set should be commutative with respect to plus and with respect to dot. The fourth condition is that dot has to be distributive over plus and plus has to be distributive over dot. So what do we mean when we say that dot has to be distributive over plus is that x dot y plus z should result in x dot y plus x dot z, and x plus y dot z should be equal to x plus y dot x plus z. The fifth condition is that for every element x belonging to B, there should exist an element x prime which belongs to B, such that x plus x prime will result in 1. 1 was the identity element with respect to dot, and x dot x prime should result in 0, where 0 was the identity element with respect to plus. And this element x prime is called the complement of x. So for every element x from the set B, there should be a corresponding element from set B which will be the complement of x. And the last condition is that there should exist at least two elements in the set B such that x is not equal to y. So if we can define the two binary operators dot and plus in such a way that these 6 conditions are satisfied, then we will have a Boolean algebra. Now let us look at a 4-valued Boolean algebra. So we consider a set which has 4 elements, 0, a, b and 1. And now let us define the dot operation using this table. So this is the definition of the dot operation. It says that 0 dot 0 is equal to 0, 0 dot a is equal to 0, 0 dot b is equal to 0, 0 dot 1 is equal to 0, and similarly a dot 0 is equal to 0, a dot a is equal to a dot b is equal to 0, and a dot 1 is equal to a, and similarly. So this table defines the binary operation dot, and we also need a definition for the binary operation plus, and this table defines the binary operation plus. It says that 0 plus 0 is equal to 0, 0 plus a is equal to 1, 0 plus b is equal to 1, and 0 plus 1 is equal to 1. Now if we define the two binary operators in this way, you can test out all the 6 conditions that are required for a system to be a Boolean algebra, and you will find out that these two definitions of dot and plus will satisfy all the 6 conditions that we studied just now. For example, if you look at the commutative law, you will see that a dot b is equal to 0, and if it has to be commutative, then a dot b should be equal to b dot a, And now let us look at b dot a. B dot a is also 0. So a dot b is equal to 0 and b dot a is also equal to 0. So we can say that a dot b is equal to b dot a. So like that you can test out all the 6 conditions and you will see that these two definitions in fact satisfy all the 6 conditions, and hence this system is a 4-valued Boolean algebra. Now if I ask you what is the complement of A, will you be able to find it? What is the complement of A? If you remember, the complement of A is defined as so you have to find another element x prime from the set B such that it satisfies these two conditions. A plus that element should be equal to 1 and A dot the same element should be equal to 0. So if you have to find out the complement of A, then A plus that element should result in 1. 1 is the identity element with respect to dot. And we see that there are two possibilities for the complement of A, because A plus B gives you 1 and A plus 1 also gives you 1. So either of these two can be the complement of A. 0 cannot be the complement of A because A plus 0 is not equal to 1. The condition says that for an element to be a complement of A plus that element should be equal to 1. And here we see that A plus 0 is equal to A. It is not equal to 1. Hence 0 cannot be a complement of A. But either B or 1 can be the complement of A. Now to find out exactly which one will be the complement of B, we have to consider the other condition which says that A dot A prime should be equal to 0. So now let us look at these two elements B and 1, and we see that A dot 1 is not equal to 0. A dot 1 is equal to A, and hence 1 cannot be the complement of A. However, A dot B is equal to 0. So finally we can say that the complement of A is actually B. Why? Because it satisfies both the conditions that A plus B is equal to 1, the identity element with respect to dot, and A dot B is equal to 0, which is the identity element with respect to plus. So like this you can test out all the different things and you'll see that in fact these two operations, the way we have defined them, satisfies the 6 conditions of Boolean algebra, and hence this is a 4-valued Boolean algebra. Now let us talk about a 2-valued Boolean algebra. So we consider the set to be comprising of two elements 0 and 1, and we define the dot operation in this way. 0.0 is 0, 0.1 is 0, 1.0 is 0, and 1.1 is 1. And we define the plus operators in this way, which is 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, and 1 plus 1 is 1. And if we define the two operators in this way, you will see that this system satisfies all the 6 conditions that are required to be Boolean algebra, and hence we can say that this is a 2-valued Boolean algebra. And now we can summarize the postulates of and theorems of Boolean algebra in this table. So from the definition of Boolean algebra we get the postulates. For example, postulate 2 says that x plus 0 should be equal to 0 and x dot 1 should be equal to 1. This should be 1. And postulate B says that x plus x prime should be equal to 1 and x dot x prime should be equal to 0. Postulate 3 says that commutative x plus y should be equal to y plus x. and similarly. And now this table also lists the theorems. So postulates comes from the definition of the Boolean algebra, whereas the theorems we can derive using the postulates. And theorem number 1 says that x plus x should be equal to x and x dot x should be equal to x. Theorem 2 says that x plus 1 should be equal to 1 and x dot 0 should be equal to 0, and so on. And here we have the De Morgan's theorem, which says that the complement of x plus y will be equal to x prime dot y prime, and the complement of x dot y will be equal to x prime plus y prime. And then we have the absorption law, which says that x plus x dot y will be equal to x, and x dot x plus y will also be equal to x. So this table lists the postulates and theorems of Boolean algebra, and actually this is all that I have for today's class. Please note that correction, this should be x dot 1 should be equal to 1. And with this I will like to end today's class. We'll meet again in the next class. Thank you. Bye.